and welcome to another episode of FooBar. Today we are going to continue talking about the well-architected framework, and in this episode we are going to talk about the first of the pillars, that is the operational excellence pillar. If you don't have a clue what the well-architected framework is and you want to know, I have done a video getting you started on that. The link is in the description box. So I will not cover all that. Now we just go directly to the pillar because that's a long one. So what is this pillar about? Every pillar has a different reason to exist, and this one is all about developing, running, and maintaining effectively your operations in your organization, in your products, in whatever you're doing. So in this video, we are going to talk a lot about DevOps practices. We are going to talk about infrastructure as code. We are going to talk about automatization. We are going to talk about observability. So that's what is going to happen today. Some things that you have to have in mind, some design principles for this pillar are perform operations as code. We all know that, but we will go more in depth in that. Make frequent, reversible, and small changes. That's one of the bases of continuous integration, that you want to keep on pushing things to the repo and building and testing it. And then review and refine your operations frequently, and that's something that is very important, and you will see in this pillar that is all about iteration and feedback and learning, so that's super important. And then learn and anticipate failure. Everything fails all the time, as Mr. Werner Vogel says, and here is all about looking at learning from your failure and looking at what can fail in the future. So this pillar is organized in 4 areas or best practices, or I like to call them steps because I think they kind of need to happen in this order. This first step or area, as the document call it, is the organization area. And basically here you will get your things together. You will understand where your business priorities are, what the responsibilities of every team and every member of the organization is. You will make sure that everybody is aware of what they are responsible for. So that's the first one. The second one is getting ready, like the prepare area or the prepare step. And in here is basically design these workloads and these operations in a way that you can get an understandable output of these workloads. So when you are planning your workloads, you want them to be able to tell you something and not just execute and you need to guess. So that's the prepare part. Then we have the operation part, the operate part. And this is a step where basically I will be doing a lot of talking. And this is the operate part in the operational excellence, I will say. Here is where I will show you demos and I will show you how to implement everything. So stay tuned for that. And the last step area, or whatever you like to call them, is the evolve. And this is the evolve, learn from what you have experienced, iterate, share, and improve and continuously improve. So this video is going to get kind of organized in these 4 areas, but I have to be honest, the 3 of the 4 areas are quite short. Let's talk about organize, prepare, and evolve. Those are quite short. The one that we are going to focus a lot is the operation part, the operate part. So yeah, you will find chapters of all the kind of where all these areas start and what is the content inside them. So let's start with the first area, that is the organization and get everybody in the same page part. I mean, you will see that all the areas are more or less organized in the same way. They have some basic questions that you need to ask, and then some kind of design principles or ideas that will help you to address those questions. So when we talk about our organization, we talk about everybody needs to know what they are doing. Everybody needs to understand the business, what your business is doing. Everybody needs to understand what are the business priorities and have priorities. Everybody needs to know the responsibility in a level of a team or in the level of organization. And here the questions are, how do you determine what your priorities are? Then how do you structure your organization to support your business outcome? And then how does your organization culture support your business outcome? And these questions can be addressed by different strategies that they are listed in the well-architected framework, but here is just a kind of summary of some of the most important. Make sure that you have owners for every component, application, process, whatever you do. Having owners is critical to improve the performance of a component. If nobody owns it, that component is kind of dead. If too many people owns it, nobody takes responsibility. So have one clear owner for every piece of your application or your organization. Make sure that the owner and the people around your organization understands the business value of each component and why we own it. Sometimes this is, I saw it a lot in different organizations, that we want to build as engineers, we want to build everything from scratch. And because it's fun, it's a challenge, but it doesn't make sense to own those pieces of components or those pieces of software, because that requires maintenance, that requires a lot of things, and those are not aligned to the business that we are doing. So, for example, hosting all your, your logs and build your own log system, or building your own authentication system for your application when you can use a library or you can use a third-party services. You need to have a very clear reason why you own that. Is that crucial for your application that you definitely cannot exist if everything else is down? Then maybe you need to own it. But if it's not that important, maybe you need to think that about. So this is making you think about those things. Another one is evaluation of risks. And here is important also to document those risks. So again, we go to the reasons of why you own what. And sometimes you hear from the engineering teams that they say, well, I want to build my authentication component because what happens is the third party goes down. And then they don't understand that, well, if, for example, they're hosted in the cloud, if the whole cloud provider is down or the service is having issues in a bigger level, then the authentication will be less of the problems. And then also look at the cloud providers' SLAs and reports how much they are really down, and it's a real risk. Like, that's something you need to evaluate, whoever is your provider, and it can be a cloud provider or it can be a third-party provider, but try to figure out if it's a real risk that they are down, or it's more risky that you are down. So that's something also I have heard about. What if we want to migrate? Imagine that the price goes up and then we will be locked down. Well, is that a real risk, or that's something that it's kind of making your brain a little bit annoyed because you really don't like to be all in one platform? And if you really cannot be all in one platform, state the risk and why are you not doing that? Some organizations cannot be all in one provider or in one platform, or they need to be able to migrate in a kind of matter of really short time. You might have your own restrictions and you might have your own situations. So in this moment is the time to address those situations and understand what are real risks and what are like your engineering team wanting to implement everything from scratch. Then here it's also important to create a safe place for experimentation and trying new things and learning and education. So this is the part of the culture, to build a culture that is safe, that is embrace failure and embrace experimentation and embrace learning, and people are not look weird for trying new things and suggested new things. And this is the place that you are going to develop those things. So this is more a cultural change than maybe kind of technology change, but the technology in the operate step will help you to create a technology-wise safer environment for your developers and architects to experiment. But this is about the culture, about the embracing and having processes like, for example, if something goes wrong, how you manage those situations, what you do in the case that there is a failure. Do you do a post-mortem? You try to make them that you're not blaming anybody and everybody feels safe when that happens and they learn something about it. So this is the part that you do that. So now we go to the phase of preparation. So now we are thinking about our workloads. We are getting more into the technical aspects, and we want to make sure that our workloads are able to provide all the information that we'll need to know later in the operations part, like information about their state and how the application is doing and how it's performing and everything that we need. This is the part that you prepare your workload for that. So the questions that this area asks are questions like, how do you design your workload so it can understand the state, so you can understand the state? How do you reduce the defects, ease remediations, and improve flow to production of your workload? How do you mitigate deployment risks? How do you know that you're ready to support a workload? And this is all about design and planning of your workload. A lot of these things will get solved with a CI/CD pipeline that we will see in the next phase, how we can start looking at that. Basically approaching the fast feedback phenomenon that you want to get from an error being discovered to the error being solved in production super fast. And that's something we will measure in this stage, for example. Then we want to do small changes that are easy to reverse and easy to test, and they go fast to production. We want to have a consistent way to create changes in production, either having a process that is automated and also have a place where we record the changes into production. It can be a remote repository, tickets, or whatever you do, but have a process for that. Other things on this stage get addressed with DevOps processes, like have runbooks for normal routines, infrastructure as code, have playbooks when things go wrong and what you learn from them, so you can fix and if something happens again, you can go and check that playbook and see what is going on. Have multiple environments, again, create environments easily so your developers can experiment. So all this is in this preparation phase. So if you're still here and you're about to hear me rant for the operations part, that is the most interesting one, and you have not yet liked this button, what you waiting for? I'm waiting. Like it? Like it. Thank you. So let's continue. Now I'm going to talk about the operate phase. And this is the core part of the operational excellence pillar, in my opinion. But if you have not done the pre-work in the organize and in the prepare phase, this is kind of hard to have completely done correctly. So the questions that we are going to answer here are, how do you understand the health of your workload, of your application? How do you understand the health of your operations? And how do you manage the workload and operational events? And here I will add two more questions, and these are the ones that I'm going to answer because I think they answer the other questions in a way. And this comes from the serverless lens because we want to focus on serverless applications. I told you in the previous video, and I forgot to tell you again. So the question that the serverless lens asks us is, how do you understand the health of your serverless application, and how do you approach application lifecycle management? So these are the two questions I want to address, and I will start with the first one. How do you understand the health of your serverless application? And here we need to look at the observability triad: metrics, logs, and tracing. So this is the kind of pillars of observability, and we need to implement those things within our applications and in our workloads in order for them to tell us something about their state. So logs are basically timestamp records that we do in some moment and with information that we want to push. They're very discrete, like now we put this in the database, we decide what to write in the blog. So that's something we will write. Then we have metrics that usually they gather some kind of numerical data about things that help us to track our application health. They can be things like more operational things, like so many lambdas were successful, or so many lambdas were throttled, or so many failures, or so many 404, or they can be things about your application execution business logic, like we have so many people registered today, or we have so many views, or we have so many sessions, or I don't know, something. Traces are end-to-end transactions, so we will get some, not all of them. So this is something that we will sample. You don't get all the traces, but you sample your executions and you get some from end-to-end that goes transversally through your whole application, so you can understand the transaction journey, understand the bottlenecks, understand how everything connects together. And then basically, if we want to implement this with AWS, then we will have these services that are for logs. We have CloudWatch logs, and then we have CloudWatch Insights. I show you how to do this in one of my videos. All the links for this are in the description box. There will be a lot of links, because I'm not going over myself. But I have made a video about that, about structured logs, and about CloudWatch Insights and how you do it and how you implement it in your serverless application. Then we have for metrics, CloudWatch metrics, the dashboards, and the alarms. The alarms are critical to tell you when something is wrong, so you don't need to be watching that dashboard all the time. And I also made a video on how you create alarms, how you create metrics, and how you see these in a dashboard. So video in the description box. And finally, we talk about traces, and we talk about X-Ray, AWS X-Ray, that help us to create traceability in our application. We can see the distributed tracing going from synchronous process to asynchronous process, like event bridge or queues or things in the way. And then how we can put logs, metrics, and traces in one place using the CloudWatch service lens. All that is in a video on how you do it with AWS Serverless and SAM and all that stuff. So go and check those videos. So now you have the videos and you have the question that those videos answer. So let's go to the other question that the serverless lens put on us. That is, how do you approach the life cycle management of your application? So applications in general have more or less a similar life cycle. We code, we build, we deploy, we test, I hope, and then we go to production. You might have 1, 2, 3, 27 different environments in place. But at the end of the day, it's the same. If you prototype, if you experiment, you might want to build and test, and then that might not go to production, but still, or you have a very brave team and they can just put things into source and go directly to production. So at the end of the day, it differs from team to team and the needs and the applications that you're doing, but these 4 phases are present everywhere. So the key here is to automate as much as we want on the life cycle of our application. We want to focus on coding our business logic. We don't want to focus on anything else. So we are going to talk about infrastructure as code, CI/CD pipelines, continuous integration and continuous delivery or deployment pipelines, environments, having multiple environments like development, testing, production, one environment per developer, whatever you're mashing. Then we are going to talk about application configuration management, that is fundamental to be able to do infrastructure as code and have multiple environments in a sane way. And then we will talk about testing. And I will show you a lot of links again, because I already talked about everything. So I want to start first telling you that I have covered all these 4 serverless applications, all the lifecycle management in my reInvent 2020 conference talk. The link is in the description box. You can go there and watch it. It's a 30-minute talk. It's all about CloudFormation. So That's kind of the drawback, because in that time, that's what I was doing. And then I will share with you more links on how to do with CDK and other tools as well. But that talk covers everything basically, and it has a story on how things move from one part to another. So that's kind of my first recommendation. If you only watch one video after this, that can be very helpful. So when we talk about infrastructure as code, there is so many options. Nowadays, you can do CloudFormation, you can do SAM, you can do CDK, you can do Amplify, you can do Serverless Framework, you can do others. And for all of those, I have different beginner videos that you can go and check in the playlist I leave you in the description box. So you can learn a little bit about all these different infrastructure as code. And if you don't know, you're not aware when to use one or the other, I owe you a video on that. I have one video that is a couple of years old and I want to make a new one, so stay tuned for that. Then when it comes to CI/CD pipelines, again, we have multiple ways of doing them. We can do that with code pipelines. We can do them with GitHub Actions or GitLab. We can do it with Jenkins. I don't know, whatever you imagine. The important thing is not the tool that you use, but is that you have one in place. And here, when we talk about CI/CD pipelines, I also want to talk about environments. I want to talk about having multiple environments in these pipelines. And here we can talk again, what kind of deployment strategy you use. Do you will, for example, multi-branch strategy, that you have a development branch and then a production branch, and then you deploy to that dev branch, and then you merge the code, and then it goes to dev. I call it Git flow. I don't know if that's the right terminology. Or then you have an all-in strategy where you just push to one branch and it will go to a development stage, everything automated, run integration test, and then push to production without you doing anything. That's one way. Another way is to have like different everything and do everything manually. Please don't do that. But again, it depends on what are your needs. So depending on what you need, the strategy that you have to build. I have videos on all these strategies, and I have videos on so many of these technologies. I leave you the link down there in the description box. Also important in this part is to talk about the different deployment strategies for your code. So for example, when we talk about serverless applications, we talk about strategies like Canary or Linear that are supported by code deploy. And meaning that you can deploy your Lambda functions and run integration tests before deploying, then deploy them in a way that they are gradually getting into production, so you can make sure and monitor that everything is right, and then run integration tests when they are finished. So this is a great way of doing deployments in a very, very safe way. A lot of the patterns in CI/CD and multiple environments are based on the of that building environments is so cheap when you're doing serverless applications. You only pay for what you use. So if you create an environment for Marcia to test the whole application, it's okay. While Marcia is testing, you might be paying something, but then you remove the environment as easy as you created it, and you don't pay anything else. And if you leave it up, if nobody's using it, you might not pay for more than the storage. So for the application configuration management, things that are important for you to learn, they're critical, because if you're doing infrastructure as code and multiple environments and you don't have application configuration in place, you will be nuts. You will be creating a lot of duplicated code inside your infrastructure as code part. So say, this is production, this is dev, this is that, and just giving names and giving attributes and giving lots of things that can be resolved with environmental variables, basically. That every environment has a different set of environments, but they all run exactly the same code. So for that, basic services to get to know are the parameter store, KMS, because you might want to encrypt some of those values in the parameter store. Also the secret manager. The secret manager is great. It's super easy to use. it's a little bit expensive, so that's why I encourage KMS and the parameter store. And then if you really need to juggle around and do more interesting things with your application configuration, you might want to check app config service that will do a lot of this for you. So I'll leave you in the description box a playlist with videos about these topics. So we are reaching the end and we will talk about testing. Congrats for the ones staying until here. So testing, I think it's one of those recurrent things that we all developers want to know more about and we never implement. But yeah, when you talk about serverless applications, you can do testing in so many places. So it's important to be aware of that there is not only one type of test that you can do. So you can do code reviews. Yes, you can do those. You can add some machine learning to your code reviews. If you're using Java, you can do Code Guru, for example, or then you can have some libraries running and checking your code. There is many libraries that are open source or services that you can integrate, or then have good senior developers that look at your code and review it. Then when we talk about unit test and the build phase itself, you can automate the unit test running. Unit tests are super important. You should not do millions of them. If your Lambda functions are simple enough, you don't need a lot of unit tests because they are important, but they are not as important than in a traditional application. Also, you can test your infrastructure. So you can create, for example, with CDK, you can create CDK tests in your infrastructure to make sure that you are creating the right infrastructure. You can also add linting to make sure that you have the right format for your application and everything is right. So for example, if you have a YAML, you might want to run some lintings before starting to deploy that because it might fail because it's not correctly formatted. So all those things you can do in the build phase as an automated process. Then when we come to the integration part, you deploy your application and what you do there, well, you create integration tests. Here you can have it against the real cloud services, build environments for your testing, or then you can have it against in the sandbox accounts or fake accounts if your third party doesn't support this type of environment. So it's good to have, sometimes you need to mock those third parties. So for example, if you're doing a payment, sometimes the payment third party might allow you to have a mock system, sometimes they don't, so you need to think about these things here. For running integration tests, I like to use Lambda functions. Lambda functions are great. You can integrate them directly in the code pipeline as kind of action within the pipeline. You can pass parameters in and you can pass parameters out. So it's kind of really easy way to do integration tests without really needing to have a server or anything running in there. So basically the things finish deploying, building the, CloudFormation stack, putting everything up. And then the next step is a Lambda function that runs some integration test and make sure that things work and everything is good. And also it can tear down things as well. Another thing that we sometimes forgot when we talk about serverless applications is load testing. And load testing is an interesting one. There is many libraries. I like this one called Artillery. I have a video on how to set it up. You can run it from an EC2 machine if you don't want to run it in your machine. You can add it in your CI/CD. You can build a script. You can do a lot with it. If you want to know how to do load testing in your CI/CD, let me know in the comments box. But load testing is an interesting one because we think serverless is scalable until the end. And yes and no. There is soft limits, there is services that might scale in a way and services that might not scale that well. There's third-party integrations that might not like your serverless applications. So having load testing in place to make sure that your application can support the load that you expect is fundamental. Also, load tests help you to know how much it will cost. But yeah, so I recommend you to have a suite of load tests, and maybe you don't need to run it for a deployment, but whenever you do some major changes in your application, run them and make sure that everything is good. And finally, after you go to production or when you are going to production, use code deploy with these kind of safe deployments with the linear or the canary, or even a just all-in deployment where you can run integration tests before to make sure that your environment was stable, deploy, and then run integration tests afterwards to make sure that your changes didn't break everything up. Again, integration tests can be created as Lambda functions, so it should be quite simple. And that's it. That's all in the operate thing. I forgot, I have videos on testing. Links in the description box. So now you have videos on observability, you have videos on CI/CD, you have videos on infrastructure as code, you have videos on application management, you have videos on testing. You can do this pillar like a boss. The last phase is the evolve phase, and this is a short one that addresses how you can evolve your operations, meaning what you're learning and how you're going to improve. All these videos I show you, there are a lot of information, and if you're starting from zero, you will not implement everything right away, and you might not need to implement everything right away. So this is the part that you are evaluating if what you have in place is right for you in your current situation and what you want to do next. And then create a plan, organize, prepare, operate, and then evolve. This is very important to have feedback mechanisms, have metrics on your operations to tell you how fast you're deploying, how many deployments you're doing, how many errors you have when deploying, I don't know. All these kind of things that might help you to make better decisions, to understand if your operations are working good. Also, it's good to have practice on this, and for that I like game days. So game days are kind of exercises that you do now and then where you break something in your organization, and then you need to start kind of feeling who is the responsible person, how we can fix, what is the process, what is the playbook, how we can run this, and then you can automate all this with some chaos engineering exercises, but that's for another video. I have talked about with chaos engineer with Adrian Horsby, so also I have a video on that. So that's it for me today. I will stop talking because you might have a headache right now, and I hope you enjoyed this video. Let me know if you like this video. If you don't, let me know what you would like to see in the security pillar, because that's coming next and I have not done it yet, so I would like to know how I can make this better for serving your purposes. So thank you again and have a great day. Ciao, ciao!